Thank you very much. And I know I'm fully aware I'm standing between you and lunch break, so I'll try to keep on time. And in this session, I want to talk a little bit less about product, but more about how Dynatrace as an organization changed, how DevOps changed our organization internally. So Dynatrace, we as an organization, we've been working with a DevOps, or actually a no-ops mantra for the last probably 4.5 to 5 years. I mentioned in my earlier speech that we've brought the Dynatrace platform to the market in 2014. That coincides with the part when we also started doing no-ops. Now, no-ops means not that nobody pays attention to our operations or to our system, but we do not have a dedicated operations team. There is nobody 24/7 sitting somewhere watching if everything's going on. We do, however, have a team of 8 people that focus on automation. So they are very well responsible for our platform that you as our customers leverage and use. But they're not just sitting there monitoring it, they're actually making sure that if something happens, they don't need to manually intervene and the system can heal and can work on its own. Just to give you an idea of scale, right now our SaaS platform worldwide has around 7,500 tenants. So a tenant is basically an environment that a customer leverages. Behind that, there is around 24, actually I think we're right now spinning up the 25th cluster in AWS. So it's not just one system, but it's actually 25 systems they need to take care of. And in addition, this team's also responsible for Dynatrace Managed, where you install Dynatrace in your data center. Nevertheless, we take over responsibility for making sure that Dynatrace, our software, runs properly. And right now we have about more than 1,200 clusters running worldwide if you include all the trials and proof of concepts. Now, if you add up those numbers, and I just did the numbers for SaaS because it was easier for me to get the data on that platform, that means around 7,500 times every single day something gets deployed somewhere. A customer deploys an agent, we deploy a hotfix, clusters, various backend systems. So this system is one that is constantly changing, that is constantly updated. Behind it, our DevOps team is responsible for around 1,300 instances. So we are, apologies to the Microsoft colleagues using AWS, means we have around 1,300 EC2 instances that together make up all our environments, not just production, but I'll later on also talk about how we leverage sprint acceptance, the various stages of our build pipeline. And with this approach, we've been able to achieve at least 99.99% of availability, which is quite a bit above the SLAs that we have been committing to. Now let's talk a little bit about how this has changed. And it has, to be honest, been a very profound change. In 2011, we've been an organization that built software. Traditionally, we delivered it twice a year. Our customers got it, installed it, used it, and guess what? Every single production bug was found by customers. Because we ran no production systems. We just built software, shipped it, and then you as our customer base, every bug you found was potentially as in a production system. Because for us, it doesn't make a difference where you run it. You as a customer, if you found a problem, we treat it as a production issue. Now, 2017, actually this is when we fully completed the switch. It hasn't changed since. We now deploy or deliver 26 releases. Honestly, most years it's 25 releases because most years actually around Christmas we skip one release to give the people a little bit more on vacation time, a little bit less pressure. But fundamentally, our mantra has been a deliverable every 2 weeks. Now, if you know a little bit about development, I don't have to tell you how much of a mindset change that required with our engineering teams. Getting them out of build something for 3 months, stabilize it for a month, test it, ship it, and start again from scratch to you're constantly shipping. You're constantly in a period of it needs to be rock solid. It needs to be performing because right now only about 7% of bugs are found by our customers. The other 93% are either found in the earlier stages of the build pipeline or they are found in production before a customer even realizes this. So if you're already a customer of Dynatrace, I hope you haven't had the situation yet, but it could happen that somebody else opens a support ticket for you. That's our DevOps team. They recognized something in your cluster not going right. and they open the ticket very often before you're even aware that something has been going on, and sometimes we even manage to deploy the fix before that happens. So the magic 20/80 rule also fits very well for this change. If you ask our engineers, if you ask our product management, those that have been around long enough to live through that transformation, they would agree that only about 20% of the change we did was technology change. Of course, we needed to have a more robust build pipeline, we needed certain specific systems, but a lot of it was around culture, it was around mindset. And the whole thing for us started with our CTO at the time doing something quite different, because our CTO is really a very technical person. So he's the one, if he would be in the room, he could argue with you which wireless router is better and worse compared to other ones. But what he started with to say is, you know what, DevOps, I'm going to explain DevOps on a very, very basic level, not on a technical level, to ensure that everyone understands what we are trying to achieve. Because as I said, it's a culture change. It's not a technical thing or a technical change. And the analogy that he used, that I'm going to reuse, is a digital, or actually not a digital camera, a camera. Most of us in the room are old enough to still remember there was a time before digital when there was actually something like a film inside of cameras. And towards the end of that technology, there was like boxes that literally you could get a very cheap camera, could take 24 pictures, and then you would send the camera in for somebody to develop the film, which means that you also gave somebody else the quality control. They made sure you have the correct brightness and you at least get a chance of seeing something on your picture. That's when you then got them back. Very often you picked them up in a shop. They were not even mailed home to you, but you had to go somewhere, pick them up. And that's the first time you get feedback. Literally weeks after you've taken the pictures, in some cases only after you've returned back home from your vacation. Which means very often late feedback leads to frustration. Because the pictures didn't turn out as you thought they would. It actually, you don't recognize, you don't see what you wanted to see. Somebody else took the picture for you and completely screwed it up. For us, if you now think how you take pictures now, that's how the situation looks like before you go into DevOps approach, where you take one feature at a time. With your camera, you take one picture at a time. And not only can you immediately see the results, you can actually optimize it before you do something with the picture. You can apply filters, you can maybe crop something out of the picture you didn't want in there. So you have a lot of control before it even hits your production system. And once it hits production system, once you tweet your picture, you put it on Instagram, Facebook, whatever platform you want to leverage, you also get immediate feedback. 5 minutes after, you have a second chance. If you don't like the picture, take another one. Make sure the feature gets right. Make sure your picture is what you really wanted to get and wanted to leverage. And if you now look at those three pictures, or the three boxes, it's not just about development, it's not just about operations, but it's also about business. And that is something that is very, very important and was very important for us to say, DevOps is not just a technical process. DevOps is not just we deliver something and it doesn't crash and it works for you, our customers, but it also means we want to deliver a feature to you. It's not enough to say, look, we deployed, it didn't break anything, hooray, we've done it. No, it only is good when we deliver a feature to you guys, and that's where the business aspect comes into play. So you'll see that throughout the next couple of slides, I like to refer to it more as biz DevOps rather than just DevOps, because DevOps for me misses one of the most important parts, business, in this cycle. So how does this now translate to Dynatrace? Dynatrace as an organization. Well, first of all, it means, as I said initially, a mindset shift. The mindset shift of the 2 major releases running on-prem to a more agile deployment scenario. You see the slide, I purposely picked an older one. It's a little bit outdated, which has a lot less deployments on there still. And our CTO literally went in a company internal meeting on stage and said, I want to have a situation where I can deploy code into production within 1 hour, fully qualified and fully tested. Engineers first didn't know if he was serious or not, then they started laughing, and then a little bit later on they realized that he was actually serious. Because you need to set aggressive goals if you want to get somewhere. If you would have, he would have set the goal, we want to be in a situation where within 2 weeks we can deploy something, I can guarantee you that it would have taken us a lot longer to ever get there. Now, it still took us a while to get to the 1 hour. Don't get me wrong. This is not something that happened overnight. I think for about 9 months, we had build pipelines that constantly broke, build pipelines that weren't up to speed. We needed to figure out where the bottlenecks are, and I can guarantee you there was a party the first time we actually deployed something with, I remember, 57 minutes between check-in and deployment to production. But it is for us an important part, and it was important because it also showed the teams that this is not just the newest trend. This is not just like, yeah, last month or last year we've done this year we're doing DevOps, next year we're going to find something else that's cool and a corporate-wide initiative. And it is something that the whole team needed to come together. This is nothing that the DevOps team achieved. This is something that the whole development organization together achieved because it needed every single one of them to make this happen. Now, making it happen does not mean in an organization that we just magically, everyone saw the light and everything started to become better. We have and had a key catalyst inside the organization. A lady, Anita Engleda, who still leads our DevOps, or she calls it the NoOps team, was the one who was empowered and had the support from our CTO to make those changes, to start implementing those things. And if you ask her, she would actually say that she owns and runs an engineering team. It's just an engineering team that has different tasks, that has different focus points than a feature team that works on the capabilities that you as our customers leverage. It's about making sure that our engineers have visibility into what's happening in acceptance, in production. It's about making sure they have mechanisms for getting feedback, but to also give them control. One of the most important things was to empower developers and architects to hold features. Not because a product manager promised it to some customer and we need to push it out and we need to hit the date. If the quality is not right, it's not right. And it sometimes is painful. And yes, sometimes it will take a lot of resolve to actually push that through and to stand up and say, no, we're not going to deploy this because we know even though a couple of customers would be happy, it would crash on 80% of the others. And it also meant that giving teams ownership of the source code across the pipeline. A developer is not just responsible for something happening in the development stage, he's also responsible for acceptance, for production, which are the 3 stages we run in: development, acceptance, production. Now, basically, they are a little bit of a mix. On the one hand, they're engineers. On the other hand, they're also production managers, in the sense of they are still overall responsible, as I mentioned initially, for the production system. So on the one hand, they work a lot on tooling, they work a lot on building the pipeline and building the systems that allow us to work in that mode. On the other hand, they are also responsible for reacting if something happens, making sure that next time we have the automation, or if it is a customer impacting problem, they are the ones who run the incident and make sure that we address it properly. And we also communicate to you, our customers, properly what has happened, what steps we have taken, and how long it took. So if you think of the whole cycle, the cycle starts on top with developing features, providing fixes, depending on what part you're working on, building, adjusting the test coverage. Obviously, automated testing is a key part of this initiative. And then think about how you migrate it and put it into production. Make sure you have the right feedback channel enabled. If I deploy a new feature, do I have the right metrics configured that I can tell if this is good or bad in production? Because not everything will be immediately visible. So I need to, as a developer, think of what would I want to know for this feature in production to get confidence that it works. Of course, then consume the feedback and also implement the feedback. It doesn't work if all you do is push new features on your developers and you never give them time to actually consume and react to the feedback they're getting. The first 2 parts are what's typically called continuous integration, which focuses a lot on automation, building, testing, making sure this is a robust pipeline. The rest of the part, CDF, continuous delivery and feedback, that's where for us the larger part of the work actually resides. Not the continuous integration part, which we've done for a lot longer than since 2014, but it's the continuous delivery and feedback. So let me talk a little bit about a couple of tasks that we had to solve or fulfill in that area. Now, one key thing was our CTO made architects responsible for production. What this means is if during the night we run into an issue that cannot be auto-corrected, the architects are among the first employees that will be woken up. Not just a production, not just an operations team or development team, the architect team. And I can't underscore how that profoundly has changed how they view features. How they now think about scalability. Now they think about, what does this mean if I say, yes, this is ready for production? Is it something that for the next 3 nights I'll be getting up because something needs to be fixed? Because initially they got up a lot during the nights. But it's, again, the culture change. It's not the 20% of the technology change, it's the mindset change that was important. Now, I'll talk a lot more about this in the afternoon or after the lunch break in the DevOps breakout track, but it also means you need to have the infrastructure that allows you to follow this automation through. In our case, that means we decided for AWS because when we started this in 2012, AWS was way ahead of everyone else when it came to automation interfaces. I would say by now we probably would have a lot wider choice because between AWS, Azure, Google's cloud platform and some on-prem platforms like Kubernetes, we would have a much wider choice which of them we pick because they all have very good interfaces and very capable automation interfaces. And the reason for that, why that is important for us is if you want to automate, and if I want to, for example, automatically scale up because a large customer comes online during the night European time, I need a system that can spin up a new instance automatically and not one where I need to fill out a form so that somebody creates a new VMware instance for me that 2 weeks later I then have available and can start. I need an API to fully automate that. Now, the same deployment in every stages. No manual touches. Everything from development, acceptance, production uses the same automation scripts. Because that's one of the things that we initially had problems with, that only in production we ran into those issues. Because that's the first time we actually tried our automation scripts. Same monitoring in every stage. Same visibility in every stage. Obviously another important part. The direct feedback. Engineers, if you want to empower them, you also got to give them data. Now that has... I come and live within the European Union, which means data protection is something that we care about very deeply, which also means there is some legal challenges around that. What data can you give developers access to? What do you need to make sure you hide? Because obviously not every customer data can immediately be shared with an engineer. But that's a legal problem that can and needs to be solved. You can't solve it by saying nobody can touch production other than a selected few. That's not the answer for that issue. It also means we need to give our engineers control. Obviously, if we expect them to be responsible, we also need to make sure they can and do affect the changes. And last but not least, I'll talk a little more about this a little bit later. It does not mean that everything happens within 2-week cycles. There are changes and there are fixes where 2 weeks is not acceptable, where we need the 1 hour because something is bad has happened and we need to do changes, fixes rapidly. So let me pick out 4 of those in the remaining 15 minutes to talk a little bit more details about those. And I picked specifically the ones that are now in purple because obviously making an architect responsible for production, there's not a lot more that I could tell you about that. So same deployment in every stage. No manual touches. Have a build pipeline that really is fully automated from checking in your code at the beginning throughout all the stages. In our case, this means we needed to build an automation layer. We needed to spend time, and we spent quite a bit of time on making sure that obviously running a SaaS platform for monitoring is nothing where you can just buy an off-the-shelf build pipeline that is custom built for exactly what we needed. So we spent quite a bit of time on making sure we have the framework for all that automation that runs or can run the specific tests we need to run, because not everything we do can really be covered by unit tests. If you think about the one agent and what it does, it is something where we needed specific tooling to make sure we can also automate those tests. And this also means this orchestration layer has a separate feature team. It is for us a part of our product, like we have an agent for log files, like we have a team that focuses on the UI. We have a team that just focuses on making sure our orchestration layer works and is capable of delivering what our DevOps team needs. Now, I mentioned a couple of times already the stages. We have the development stage at the beginning, which is something where every day a new build is triggered and is tested and deployed so that developers get the early feedback. We have in the middle the acceptance stage, which is built or created actually 3 times a week. Bi-daily is the best English word I found for that approach. And then we have the production stage where we already talked about every 2 weeks something gets deployed there. Now, having the same tooling and the same monitoring across all those stages was important for us. It will not surprise you that we leverage our own products for monitoring, also Dynatrace in production. So we have the same systems monitoring all those things. And we have, as said, outside of data protection requirements, the same access to everything. There is no reason why an architect should not be allowed to look at production to understand better what he's deployed there, so that he can make the right adjustments and that he can leverage this feedback loop effectively. So commonality across the stages is really an important part. Commonality in how you deploy, how you build, but also how you monitor, so that again, in development you learn what needs to be monitored in production. Not when it hits production and then after the fact you try to figure out which metrics are relevant or should be paid attention to. Now, direct feedback also means that we need to somehow visualize what's actually going on. Engineers want to understand what's happening, how is it happening. In our case, and that is a quite old picture by now, there's a lot more dots on those stages, but that actually is a view over about 3 weeks and all the changes that happened. All the deployments, all the changes behind each of those dots. There's a link into what code change was actually triggered there. And you see that towards the bottom in development, we very frequently change. At the bottom in production, we have a lot less frequent changes. Because again, visibility is important. Making sure that as an engineer, I know when was this feature deployed in production? Should I be paying attention to production, or is it still a week out before it even hits that stage? Direct feedback also means finding, I would say, new ways of how you can visualize data for your engineers. In our case, one of the architects had the idea of saying, you know what? If we are having a coffee, if we're sitting in our cafeteria in our labs, we never know, should we be enjoying our coffee because everything's green, or should we rush back to our desks because what we've done before grabbing a coffee actually broke something? And what he came up with initially was a small 3D printed device, which you can see hanging from the ceiling here, which he called a UFO, simply because of the shape that it has. And what it is or does is very simple. It visualizes the stages of our build pipeline. You can see on top is the build pipeline for development. On bottom is the one that builds the latest sprint environment, so it's the middle stage. And if it's green, nothing to worry. If there's a green cycle that turns around, it means it's actually currently running and building. If it starts to blink red, then better get your, apologies my French, ass back to your desk and fix something because the build pipeline's broken. Small things. Started with one of them next to the cafeteria. By now, most teams actually have their individual ones because they say, I also want to know if my specific team broke something or if we have a general issue that maybe somebody else is responsible for or should be looking after. Automated feedback also means providing a mechanism or providing a capability for engineers to define what is expected behavior. This specific engineer, Thomas, actually called this a performance signature, and the performance signature is nothing more than saying for this specific code, he expects the response time to be below a certain value. If it goes above this value, our build pipeline will automatically stop this build. It is as if we have a failed test. Exactly same thing. It's a quality gate. If this test does not meet this performance signature, gets stopped, gets fed back to him, and it's again very direct feedback. I did something that broke this specific part of our application. And what this then really meant that when we put the control about what should be pushed or put into production into our engineers' hand after, quite honestly, a rough couple of first months. It's not. I'm not talking about the promised land that everything from day one will be completely perfect, but it really led to a culture change. It really led to a point where engineers suddenly got, I would say, almost they started to get proud of their features in production. They didn't want to hear that they broke something in production. They took a lot more care, but they also took a lot more motivation out of, look, I now know how my feature is used. I see that 100 customers have already started using what I've implemented, and it works for all of them. So don't just see this as a negative thing of like, well, you didn't break anything. It can also be a positive thing about giving them feedback that what they do matters for you, our customers. And isn't just something that a product manager told them it needs to be built, they build it, and then they move on to something else. So working in production is an important part of this cultural cycle. Now, I mentioned this part initially, the fast lane into production. Now, every 2 weeks, we promote code from one environment to the next one. So stuff that runs into the development stage for 2 weeks, then it gets promoted into acceptance, where it runs for 2 weeks, and then basically 4 weeks after the initial check-in, it reaches production unless something else stops it there. A fast lane is important and is necessary, because sometimes we break stuff. We just write software like most of you do. So inevitably, we will break, and there will be bugs that, even though we take a lot of care, only show up when you run something in your environments. And it is, of course, not acceptable in cases like this to say, okay, yeah, we found the issue, we fixed it, don't worry, 4 weeks from now, the fix will be in your environment. Sorry, that's not the type of service we want to provide. So that's why we still have this fast lane. We still have the capability of deploying into our production system within this 1 hour cycle. And 1 hour does not mean it takes us an hour to build and compile everything, but within this 1 hour, we have smoke tests included, so that we at least make sure a very basic level of QA is done, even if the fire is literally burning and we need to make sure we get something rushed out as quickly as possible. Now, do we use this pipeline very often? Quite honestly, we don't. Right now, on average, I would say maybe once or twice a month, something comes up that requires hot fixes for specific customers that follow that process. But it is something that is required and is necessary because, as said, sometimes bad things happen and sometimes you need to push out things quickly enough. Now, let me finish with, again, a little bit of something that I'll talk a lot more in the afternoon if you're interested in, and that is, where are we going forward from now? Because what I've described now is for us the status quo, but what are the future plans that we are right now working on? And it is actually leveraging the data, leveraging the problems that I know you've heard now throughout the other sessions, a lot about how Dynatrace recognizes problems, root causes, all those things automatically and shows you the impact. What we've now started to do as a next step is to leverage this data for also automating the problem mitigation. Because if you think of Dynatrace's alerts, don't just tell you that, look, the response time here and here is bad, but they also give you a lot more information that helps you with the decision, do I need to escalate this? If this happens at 2 a.m., do I need to wake up somebody? Can it wait until the morning? Or is there something I can do to make it better without involving humans? Now, just think of, Dynatrace doesn't just tell you that the response time is slow, we also tell you a lot more about the root cause. And once I have this root cause of, for example, CPU saturation, I can start to automate the mitigation. I can use, for example, Ansible or Ansible Tower, ServiceNow. There's a lot of solutions out there that allow you the runbook automation. To say, look, if your CPU is exhausted, maybe a first quick fix is to spin up another instance. If you run Kubernetes, just deploy a second instance of that service into your environment. Or if a connection pool is exhausted, maybe you can automate to increase the connection pool and make sure that, again, you mitigate the results until somebody can work on a proper fix in the morning. If it is caused by a canary release, or if you have like a blue-green deployment where you deploy a new version into a different environment, you shift over traffic, and when you then recognize there's a problem, well, roll back. Go back to the previous release that is working. That's not rocket science. That is one of the easiest steps to automate. If your issue is caused by a new deployment, go back to the previous one. Because that's exactly what your operations team would do as a first step while they diagnose the issue. And if those steps have mitigated the impact, well then guess what? update the teams, open a ticket for them so they can make sure it next time doesn't even get to that stage. And only if the mitigation has not been successful, only then you need to wake somebody up. Because yes, there will always be issues where something unforeseen happens and you need to have a human looking at it, but you want to make sure that those precious humans that really don't like getting up at 3 a.m. in the morning, that you focus them on the right things and not on the easy things, because I for sure don't like getting up at 3 a.m. in the morning just to start another instance and then say, you know what, it's working again, go back to sleep. So that's really for us the next frontier. It's this autonomous IT, or it's something, we call it the autonomous cloud. And the autonomous cloud is not about public clouds, it's not about how you compute, but it is about building systems that are using automation, not just throughout the build pipeline, not just throughout delivery, but also push that into the operations. As said, a lot more on those topics. I'll talk about 4 initiatives, how you can get towards that stage in the afternoon session. But with now, unless there's any burning questions now, I think we are all ready for our lunch break.
The burning question. Oh, I know the man.
I try to find the price policy of Dynatrace, and it's very hard. The third Google link go into document of one company which buy Dynatrace, and this is price. And it's all in Google, this description that the product is too expensive and that it has a lot of problem with a lot of other software, because a lot of software stopped working after installing agent. It's a lot of, about 1,000 such comments that something going wrong and service stop working at all. And it's very interesting to me to find the price of the product, because we can talk long and more about that, but I can't understand. Even OTP bank says that it's too expensive for them. So where I can find the price, and what is the price policy, and do you have difference between the size of the consumer which buy this product? For example, some vendors have very flexible policy independent of the size of the company which use this product.
So actually, two questions in one. The first question on, does it break stuff? Yeah, it occasionally does, like any monitoring product does. We depend on somebody else's application. I would be lying if I stand here and say, Dynatrace never broke an application. Yes, we have. But it is about, A, how do we deal with that? That's the one part, and how quickly we fix those issues, which you will be experiencing when you try, and that is why we are so insisting on try our product. Don't trust marketing slides, and for sure, please don't trust Google comments, because I can tell you where half of those comments actually come from. That's the one aspect. If you want to know how well Dynatrace works, take a look at our list of customers. That is, in the end, the only thing you can do outside of trying it yourself is look at references. And look at what those references, you've heard some of them speaking here earlier. There's a lot of public videos, testimony up there. Do you think SAP would have bought Dynatrace for 60,000 hosts if it broke on each of those hosts? It wouldn't. Do you think we would have reached 2,000-3,000 customers worldwide if we would break every single application we ever encounter? I can guarantee you we wouldn't have been able to achieve that. And on the pricing side, yes, our price is not published. I would just answer that with another question. If you buy 1,000 BMWs, do you think you'll find the price on BMW's website? You won't. Because the reality is, if you buy more than one, the pricing will always be custom.
Usually we have some GPL price, and we can compare this price. And
you can go to the Amazon Web Store, because the Amazon Web Store is a very public place where Dynatrace is listed, so you'll find a pay-as-you-use price there. And everything else, that's why we have BAKOTECH. That's why we have a partner ecosystem. Don't ask me. I mean, you can, of course, ask Dynatrace directly. Ask BAKOTECH. They will be working with you to understand what type of environment you run, what servers you want to monitor, or maybe how many users you want to monitor. If you want to follow them like session replay, which I I think at least saw that Vlad showed that earlier. Or if you don't care about the end users and say, I only care about the backend part, and then they'll be able to tell you a price. But it really depends on too many factors to put that just out there, because the reality is, it is always a negotiation question. So like any other vendor, you will not find our prices out there like any other monitoring vendor, like any other software vendor for that purpose. Try looking for Oracle, Redshift, ask our, I'm not sure if the Microsoft colleagues in the room, follow the same policy. How much does one license of Windows 2012 cost for an organization? How many do 1,000 cost? I'll ask and work with them, and it's the same policy we follow.
May I add some comments?
Please, you just need to get the little box so that everyone can hear you.
So there was one bank that I already discussed, Bezis Bank, and we had like huge conversation and negotiation about pricing, because it's actually a small bank, and the price did not seem suitable for them. But after I heard the feedback, it was actually like the senior administrators and developers spent 1 month to resolve the problem, and with Dynatrace, similar problem is solved in 1.5 days. And it's like actual figure, I spoke with them 1 week ago. So just let them use the software and they will stop negotiating about the price, and you will feel the power of the software. It's only about like getting the answers, not just additional data, and it's only about being very, very fast.
Okay, thank you.